Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most bountiful and the most merciful. Respected all, Assalamu alaikum. My name is Muhammad Numan and this is my ID, and I'm going to present the exact differential equation, a topic of ordinary differential equation. So what is exact differential equation? First order differential equation is called exact differential equation if it is the result of a simple differentiation. The equation p of xy into y prime plus q of xy is equals to 0, or in the equivalent alternate notation, p of xy into dy is equal plus q of xy into dy is equals to 0 is exact if p of xy into q of xy. So here we will discuss the method to solve the exact differential equation. So consider the first order differential equation x into dy plus y into dx is equals to 0, which can be converted into the exact differential form of a function f of xy is equal to xy as derivative of xy is equals to 0. Similarly, the first differential equation of form m of xy into dx plus n of xy into dy equals to 0 can be represented into the differential form by taking the partial derivative of both m and n with x and y respectively. So then the equation 2 becomes partial derivative of f with respect to x into dx and the partial derivative of y into dy equals to 0. So here we see the product rule, and we are going to close the product rule. We got d of f of xy is equals to 0. In this way, the criteria for the exact differential equation becomes this, and the finalized equation is partial derivative of m with respect to y is equals to the partial derivative of n with respect to x. So here's the first example to solve the exact differential equation. So firstly, we have to discuss the exactness of this equation. To The given equation is exact because when we take the partial derivative of both of these equations, we got the same result. So in this way, we have a following system for the differential equation to find the f of xy. So now moving towards, we are going to find the exact function. So by integrating the first equation with respect to the x, we obtain x square plus y plus phi of y. Now, substituting this expression for f xy into the second equation gives us partial derivative of f is substituted by this one, and we substitute when this one we got the and we get we are doing the integration of this one, so y will be 1, and this the whole equation is equals to x square plus y phi of prime y is equal to x square plus 3y square. Here's the both x squares are cancelled, so the final equation will be phi prime of y is equals to 3y square. Finally, we need the answer for the function phi of y, so we have to integrate this. When we integrate this, we got 3y cube or y cube plus c, so that the general equation for the exact differential equation is given by x square y plus 3y cube is equal to c, where c is an arbitrary constant. So moving towards the application. Consider a sample of a certain radioactive isotope. The atom of such isotopes are unstable with a certain proportion decaying each second. In the particular, the mass m will decrease as an atom are lost with the rate of decreasing proportion to the atom. We can write this as a differential equation dm over dt is equals to minus r of m, where r is the proportionality constant, and it follows that the mass of a sample will decay exponentially with time. M is equals to m naught e raised to power minus r of t, where m is the mass of a sample at initial stages at t is equals to 0. So One important measure of the rate of exponential decay is the half-life. Given the decaying variable y is equals to y naught e raised to power minus of rt, so firstly I would like to tell you about the half-life. So what is the half-life? The half-life is the amount of time that takes for y to decrease to half of its original value. So the half-life can be obtained by the substituting y is equals to y naught over 2. So when we substitute, the equation becomes y naught over 2 is equals to y naught into e raised to power minus of rt. And the solving for the t, similarly for the growing variable, so we got y is equals to y naught e raised to power k of t, where k is a constant and greater than 0. Thank you so much for listening, and Allah Hafiz.